Hi everyone, this is a video on using oxidation numbers to analyze reactions. If we have a non-ionic equation, traditional looking equation, or something that's the net ionic equation, we can use oxidation numbers to analyze the reactions in order to do a whole bunch of things. We're able to tell if the reaction is a redox reaction or not. We can tell what was oxidized, what was reduced, what was the oxidizing agent, what was the reducing agent. There's two things to keep in mind for this process. If a substance's oxidation number increases, that means it was oxidized, and the substance was the reducing agent. The opposite is also true. If a substance's oxidation number decreases, that means the substance was reduced, and it was the oxidizing agent. Here's two examples. This first reaction is the combustion of methane. 1 mole of methane reacts with 1 mole of oxygen to make some carbon dioxide and 2 moles of water. I didn't include the states because it doesn't make a difference. The first step is to assign oxidation numbers to all of the substances involved. In a compound, hydrogen is +1. This methane has no charge, and so the one carbon must cancel off all the oxidation numbers for the hydrogen. Each hydrogen is +1. That means the carbon is -4. Here I have O2. That's the elemental form of oxygen. So its oxidation number, 0. Elements have an oxidation number of 0. On the product side, I have carbon dioxide. Oxygen in a compound gets an oxidation number of -2. The carbon dioxide does not have a charge, so the number that I'm going to assign to the carbon has to add together with the oxidation numbers of the oxygen to add up to 0. Oxygen is -2, but there's 2 of them. That makes -4. One carbon, to add up to 0 has to be +4. I have 2 waters at the back. The coefficient does not impact any of my thought process at all in terms of assigning oxidation numbers. Hydrogen in a compound is +1, oxygen is -2. After we've assigned oxidation numbers to all of the chemicals involved, we can analyze it in a whole bunch of different ways. We can see that the carbon in the methane was -4 and it ended up at +4. From -4 to +4 is an increase. If the oxidation number increases, the substance was oxidized. And it was the reducing agent. If the oxidation number goes up, that means that the chemical was oxidized. And the substance that's oxidized was the reducing agent. We can see that the oxygen went from 0 to -2. The oxygen went from 0 to -2. From 0 to -2 is a decrease. The oxidation number decreases. That means the substance was reduced. Oxygen here got reduced, and it was the oxidizing agent. It's the oxidizing agent. Finally, because we did have oxidation and reduction happening in the same reaction, we could classify this combustion as a redox reaction, Let's go through this whole process in a second example. Here we have a dichromate ion reacting with a hydrogen ion and some ethanol to produce a chromium 3 ion, a molecule of water, and acetic acid. Our first step is to assign oxidation numbers to all of the substances involved. A little bit more involved this time. We have a lot more chemicals to think about. This ion, oxygen is -2. There's 7 of them. So we have overall here -14. We have 2 chromiums that whichever charge the individual chromium has, there's going to be 2 of them, they're going to add together with all of those oxygens to add up to -2. Oxygen is -2, there's 7 of them, -14. We add in those -2 up there, it's positive is 12. We want a positive 12 here out of these chromiums, but there's 2 of them. So each one is going to be +6. 2 chromiums, each +6 makes +12. 7 oxygens, each -2, that's -14. +12, -14, that adds up to -2. We have a hydrogen ion here, a simple ion. The charge corresponds with the oxidation number, +1. This ethanol, hydrogen in a compound, is +1. They show up in 2 different places, but all of those hydrogens are +1. Oxygen, -2. The ethanol here does not carry a charge, so these 2 carbons that are involved are going to work out so that this all adds up to 0. There's 6 hydrogens. Each of them +1 makes +6. 1 oxygen at -2. +6 and -2 add up to +4. So these carbons here, the 2 of them together, have to be -4. But each of them then is -2. 2 carbons, each at -2, that's -4. Our 5 hydrogens at +1, we're at +1 now, that all adds up to +1. A -2, that's -1, and a +1. A little bit tricky there, but very doable. The chromium has a charge of 3+. The charge of an ion, a simple ion, matches its oxidation number. It's +3. We have water. Oh, hydrogen is +1. Oxygen is -2. And we have a bit of a process for the acetic acid here at the back. Hydrogen is +1, shows up in 2 different spots, but that's okay. These oxygens are all -2. We have 4 hydrogens at +1, that makes +4. We have 2 oxygens, each -2, that's -4. So the hydrogens together with the oxygens already add up to 0. So these 2 carbons are both 0. When we add all of those numbers up, it does add up to 0. The acetic acid has no charge. Now we're taking a closer look. Is there a substance whose oxidation number changed? The chromium was at +6, and it went to +3. +6 to +3. The chromium from +6 to +3. Its oxidation number went down from 6 to 3. A decrease in oxidation number means that the substance was reduced, and it was the oxidizing agent. The chromium, its number went down. So it got reduced. It was the oxidizing agent. The oxygen was -2 everywhere. Its oxidation number did not change. The hydrogen was +1 everywhere as well. Look what happened with the carbon though. The carbon was -2 and then it was 0 afterwards. The carbon from -2 0. From -2 to 0, that's going up. That's an increase. The oxidation number of the carbon increased here. It was oxidized, was the reducing agent. It's the reducing agent. Finally, because we had oxidation and reduction happening, this reaction, we could classify it as a redox reaction. We don't typically have to do all of these things in one question. We're going to be a little bit more targeted in what we're being asked to do. However, we're able to do a bunch of different things. By assigning oxidation numbers to every substance in the reaction, taking a closer look, we're able to tell if the oxidation number went up or down, if there was oxidation, reduction, and what was the oxidizing agent or the reducing agent. And I hope that helps.